Hello subscribers, welcome to Stematics tutorial. Today's video we are going to learn differential equations methods. So in that first method is variable separable method. In order to do this method in a clear format, first you need to learn the differential and integration formulas. So that link will be given in the description, which I have already made in the form of shorts. So go through that. Also please subscribe, like and share the video. Variable separable method. This is the first method we are going to see in differential equations paper. So here we are going to see the definition, the explanation of this method, and then we are going to do some example problems. So suppose if an equation is of the form m dx plus n dy equal to 0, then how to solve this equation we are going to see now. So by using variable separable method, first thing you need to do is separate x dx and y dy terms. Separate x dx and y dy terms, and then you have to apply the integration, so that you will get the answer as like separate f1 of x dx plus integral f2 of x dy equal to c. So as we have discussed here, separation of x dx terms, x a function of x, f1 of x means function of x, f2 of y here, sorry, f2 of y, this means the function which consists of only y variable. So if you integrate that with respect to x and with respect to y, then you are going to get the final solution of this differential equation. So we will see some example problems so that you will understand clearly. So let us take the first problem. The first question is given here: solve x dy plus y dx equal to 0. You need to solve this differential equation and find out the solution of this. How to find this? So we have a variable separable method. By using that we are going to do now. So now x dy equal to, I am sending this y dx to the left hand side. So what you will get? Minus y dx. Next. So as we have discussed here, separation of x dx and y dy. So separate x dx and y dy. So here I am having dx term. So I will bring this x to the right hand side and send this y to the left hand side, so that you will get x dx and y dy terms separated. So bring this y here, so it becomes 1 by y dy. If you bring this y to the left hand side, it becomes 1 by y, and take this x to the left right hand side. So you will get minus 1 by x dx. Now we have separated the variables x dx, you can see here x term and dx term, you can see here y term and dy term. Now you need to apply the integration on both sides. Integrate on both sides. So what will get? Integral 1 by y dy equal to minus, you can take outside, minus integral 1 by x dx plus c. So whenever you are integrating any function or any function, you have to add a constant plus c. Now integration of 1 by y is log y equal to integration of 1 by x is log x. So here we have minus, so I have written that minus log x plus c. So this is a constant. You can write this in the form of constant, in the form of log, or else you can leave it like directly c. As each and every term is in the form of log here in the solution, so I am also going to do the same thing, log c. I will replace this c with log c, so that what we will get? Log, I am taking this log x to the left hand side, so we will get log y plus log x, or else log y plus log x equal to log c. Now therefore log a plus b can be written as log ab equal to log c. Since I am writing a formula, log a plus log b equal to log ab. So this we have applied here. Now applying antilog on both sides, that gives you xy equal to c. Therefore c equal to xy is the solution of this differential equation. So now let us go for another sum. We go to the second sum. Solve x square dy by dx equal to y square plus 1. So let me send this dx to the left hand right hand side first. So what it becomes? X square dy equal to y square plus 1. I'll put this whole term in one bracket into dx we got. Next, our method is separation of variables x dx and y dy terms. So here I have x and dy term. That is not good. So that is not suitable for variable separable. And here also y terms along with dx. So let us exchange this. Send this x square to the right hand side and take this y square plus 1 to the left hand side. So what does it become? 1 by y square plus 1 dy equal to 1 by x square dx. So now we got the thing, like y terms and dy terms one side, x terms dx terms on the right hand side. Now we have to apply integration. Our next step is apply integration on both sides. BS means both sides, int means integration. So I have written in a shortcut, integral 1 by x square plus 1 dy equal to, so can I write like 1 by x square as integral x power minus 2 dx? Yes, we can write, plus c. So you can add this c after integration also, your wish. Next, what is the formula for integral y square plus So integration of 1 by y square plus 1. We have a formula like integral 1 by x square plus a square equal to 1 by a tan inverse x by a. So this is the formula. Now in place of x square we have y square. In place of a square we can treat 1 as 1 square also. So you can write directly 1 by 1 tan inverse y by a, y by 1. So now I got this formula. I'll write directly tan inverse of y equal to integral x power minus 2 dx. So here we have a formula integration of x power n dx equal to, this is the basic formula in integration, x power n plus 1 by n plus 1. So now in place of n what do we have? Minus 2. So I'll write like that only, x power minus 2 plus 1 divided by minus 2 plus 1 and a constant plus c. Now tan inverse of y equal to x power minus 1 by minus 1 plus c. Tan inverse of y equal to x power minus 1 into minus 1 plus c. So this you can treat it as directly tan inverse of y equal to, x inverse can be written as 1 by x. We have minus here plus c, and take this x to the 1 by x to the left hand side. Therefore tan inverse of y plus 1 by x equal to c is the solution of this differential equation. So this is our second sum. Let's do one more sum. So third problem, dy by dx plus root of 1 minus y square by root of 1 minus x square equal to 0. So in order to solve this by variable separable method, first you need to take this term to the right hand side. So dy by dx equal to, we will get here minus root of 1 minus y square by root of 1 minus x square, because here we have plus, and if you send that to the right hand side we'll get minus. Next, so bring this root of 1 minus y square to the left hand side and take this dx to the right hand side. So what does it become? 1 by root of 1 minus y square dy equal to minus root of 1 minus x square into dx. So now we have separated the differentials, that means dx and x term, y and dy terms we have separated. Next step is what? We need to apply the integration on both sides. Apply integration on both sides. On both sides. So what do we get? Integral 1 by root of 1 minus y square dy equal to minus outside integral root of 1 by root of 1 minus x square dx. So what is the formula for this? So we have a formula, since integral 1 by root of a square minus x square equal to sine inverse x by a plus c. Sine inverse x plus sine inverse y equal to c we have got. Fourth sum, e power y plus 1 into cos x dx plus e power y sin x dy equal to 0. So same as usual, we have to check first we have x dx terms and y dy terms separated or not. So here we can see in the first term e power y plus 1 is a y term. So this is not in the form of x dx and y dy term. We will take this term to the, as usual, to the right hand side. So e power y plus 1 into cos x dx equal to, if we take this term to the right hand side we will get minus e power y sin x dy. Sorry. Now, so our next step is bringing this x term to the left hand side. That means sin x you have to bring here and e power y plus 1 you have to send to the right hand side. So what do we get? Cos x by sin x dx equal to minus e power y by, if you bring this to the right hand side you will get by formation e power y plus 1 dy. So our step 1 is finished. Cos x by sin x dx equal to, x dx terms and y dy terms, completely this function is in the form of y, and dy, this function is in the form of x, and dx term we have. Next, what is our next step? Apply integration on both sides. Apply integration on both sides. So what will get? Integral cos x by sin x dx equal to minus integral e power y by e power x plus 1 dy. So how to solve this? So we have a formula here, integral f dash of x by f of x dx equal to log f of x plus c. This is our formula. So we have to check whether we can apply this formula to this terms or not. First, if you can consider first integral. First integral. What is the first integral? Integral cos x by sin x dx. Take this as equation 1. Now we'll solve this first. Let f of x equal to sin x I'll take. According to the formula, I'm doing this. So f of x is this one. Next, f dash of x. What is the derivative of sin x? Is cos x. So according to the formula, we should have here f dash of x. Do we have this? Yes, we have. Cos x only we have. So now therefore, integral cos x by sin x dx, you can directly replace it with log f of x. What is our f of x here now? Sin x. So you can write this. You can substitute this 2 in one equation. And second integral, we'll see. Our second integral is integral e power y by e power y plus 1 dy. So now let us assume, let f of y, you can apply this formula in terms of whether it is in the form of in terms of x, y, z, the formula is same only the variables will be changing. Let f of y equal to, I am considering this denominator because here f of x is our denominator term, and that can be our f of y e power y plus 1. Now what is the derivative of this? F dash of y equal to derivative of this e power y derivative is again e power y. Since we know that e power x derivative is e power x only, plus what is the constant derivative is 0. Whether we have here 1000, 100, lakhs, whatever the number we have, only if we have only number or any constant a, b, c, you can directly replace it with 0 in terms of differentiation. So 0 equal to e power x. So therefore our f dash of y is now e power x. Our f of y is e power x, e power y plus 1. F dash of y we got as e power y. So our this term f dash of y term is c. Now I can replace whole term with log f of y plus c. Therefore integral e power y by e power y plus 1 dy equal to, I can replace it with log f of y. That means e power y plus 1. Yes, this is as equation 3. Now substitute equation 2 and 3 in, substitute 2 comma 3 in equation 1. So now this left hand side term directly can substitute with log sin x. I'll write that only, log sin x equal to, what do I have? Minus first. So minus, and in the right hand side term I can replace this integral e power x by e power x plus 1 with log f of x, log e power y plus 1, and again a constant term which you can write in the form of directly c or log terms also. I'll write in term of log only because I have here 2 log terms. Next I'll send this here. So log sin x plus log e power y plus 1 equal to log c. Now we have a formula log a plus log b equal to log ab. So directly I'll write log sin x into e power y plus 1 equal to log c. Now applying antilog on both sides gives, log will be eliminated. So our final formula is sin x into e power y plus 1 equal to c. So our final solution is sin x into e power y plus 1 into plus 1 equal to c. This is the solution of this differential equation. Our last problem is dy by dx equal to xy plus x plus y plus 1. So it is little bit clumsy type, like we have different terms here, x y plus 1. So first we need to sort out into x terms and y terms. So solution, dy by dx equal to, if you can observe here in these two terms x is the common element, so I'll take it outside. So leftover value is, if I take x common, so y will be left over here, plus if I take here in the second term x common, nothing will be left here. So let us assume this as 1, plus this y plus 1 we will treat as one term, like I'll take 1 common into 1 plus 1, y plus 1. So now this can be written as x into y plus 1 plus 1 into y plus 1 can be written as x plus 1. So into y plus 1. This is similar to like a factorization method. So here x plus 1, y plus 1 is a common in both the terms. So we can write as a one term y plus 1, and x is a common thing, here y is a common thing. So x plus 1 you can write in one bracket. So now our sorting is finished. Next thing we need to do here is take this dx term to the right hand side. So what do you get? Dy equal to x plus 1 into y plus 1 into dx. Now you can check here, I have x term, y term and dx term. So what should not be there in this term? Y term should not be there here. So send that to the left hand side. What you'll get? 1 by y plus 1 dy equal to x plus 1 into dx. Now you can check later. Now y and dy terms we have left hand side, x and dx terms. So our splitting is finished, I mean separation is finished. Now you have to apply integration on both sides. Apply integration on both sides. So integral 1 by y plus 1 dy equal to integral x plus 1 into dx. So I have already told you, like we have formulas that I'll write. Integral f dash of x by f of x dx equal to log f of x, and also we discussed integration of x power n dx equal to x power n plus 1 by n plus 1. So these formulas we have already discussed, and integration of a constant with respect to dx term is cx. So these are the same formula you can apply whether it is x variable or y variable. So f of x, then you can treat it as f of y equal to y plus 1. So differentiation of this will be 1. So consider integral 1 by y plus 1 dy equal to, same let this term we will be assuming, and sort out let f of y equal to y plus 1. So what is the differentiation of this? F dash of y equal to, y derivative is 1 plus 0. So you have f dash of y equal to 0. Now according to this formula, in place of f dash of y we have 1. Here we got 1. and in place of f of y is this one. So now therefore integral 1 by y plus 1 dy equal to, directly you can write log f of y, that means y plus 1. So this is finished. Take this as equation 2. Now consider the right hand side term. Consider integral x plus 1 into dx. So this you can split into two formats, integral x dx plus integral 1 into dx, that means dx. So integration of x power, what do you have here? 1. So here x power n, dx equal to n plus 1 by n plus 1. So that means you can write here as x power 1 plus 1 by 1 plus 1, because we treat here x power as 1 plus integration of dx. Here we have 1 as a constant. So integration of constant into dx is c into x. That means here c is 1. So I can write directly x. So no worries whether you are having here with respect to x, y or any other variable you are having. So if you are integrating only a constant, directly you will write a variable with respect to what you are integrating, that variable you will write here. So with respect to x I am integrating, so I'll write here x. Take this as, now this can be written as x square by 2 plus x. Take this as equation 3. Now substitute here in equation 1. Substitute 2 comma 3 in equation 1. Therefore left hand side equation 2 becomes what? Log of y plus 1. So I'll write here directly log of y plus 1 equal to, in place of integral x plus 1, in place of integral x plus 1 dx equal to, we have x square by 2 plus x, that only I will write, square by 2 plus x, and we forgot a constant, we need to write that constant also, plus c. So till here we got. You can leave as it is, or else you can send this x square by 2 plus x to the right hand side, you will be getting c value. Till there also you can stop the solution. That is our last sum. So those who have any doubts, you can comment in the comment section, and if you want any other topics to be explained, maths or statistics, you can comment in the comment section.